All right, thanks. Yeah, so this is the transition that has happened, right? We don't have one central location where you keep all the assets. It made sense earlier on, when we have centralized location to have a firewall or even having or to give access to those resources through a VPN, the virtual private network. Because when you are outside on a mobile node or traveling, you can come access the resource in a secure fashion, right? Whereas now, like I said, any organization is going to have so many applications and resources distributed all over the cloud, right? And then it doesn't make any sense, somebody coming through a VPN to your central location and then spinning off to go to another place to access the resources, right? So what is necessary is everybody who wants to have access should have a secure tunnel going to that particular application. That's exactly how software-defined perimeter is going to operate. All right. So this is how, based on that architectural shift, this is how the connectivity models are going to change. On the left side, that is the legacy connection model, right? Just look at it. I mean, I will just connect to the application, provide credentials, and multi-factor token, whatever. Most of the, so for example, if you go to the e-commerce site or like your bank site nowadays, and you have to use multi-factor authentication, right? But the truth is, you already know where to go to, right? You connect, and then they're verifying your credentials. So the equivalence I can give you is almost like this. Right now, the model is, I mean, let's say you're going to a hotel, right? You're saying that, okay, I want to connect to this particular room 203. You have the knowledge that your person, your friend is staying in 203. And then you are going there, and then from there, you're going inside or knocking at the door at 203. But this is the deal. When you go to the hotel, they are giving access to the whole floor. And then you can perambulate, and then you can open any door to see whether something is open. That's exactly what's happening now, right? When you have access to the system, they can come there and then just look around to see which port is open, and then you can connect, right? Whereas what we are going to say, the new deal is you don't even know where your friend is staying, right? And when you go through the authentication process, you're going to be told your friend is in 203, and you get direct access to 203. That's it. You don't have access to nowhere else, and then you don't even know who else is there, right? So the another way, the government people like to see the political connotations to this, right? When Reagan was president, he came up with a phrase that is trust but verify, right? You can trust but verify. You have to verify, make sure that they are not going to do anything nefarious, right? Whereas now the new model is verify and then trust, right? You have to verify the credentials or authenticate the credentials before you can trust. That's exactly what we do with SDP. So what is SDP? Software defined perimeter. So we don't have a physically assigned perimeter. Rather, your system is going to define the perimeter, right? So the early slide I said, the endpoint is the new perimeter. So software can define that, right? Whatever the perimeter needs to be. So some people will argue that this is the most advanced implementation of zero trust architecture. So I'm going to explain briefly how SDP works, and then you'll appreciate that this is like really zero trust. Everything is black. And then you have to authenticate yourself before you can get an opening to get into the system. So a couple of major technologies associated with it. I would say among all these things, the first thing is the most interesting one. That is a single packet authentication. That is authorization, SPA. That is something, SDP came out with. Mutual transport layer security is nothing new. If you're familiar with TLS or SSL, most of the time, it's a one-way authentication, but, SDP emphasized that it has to be mutual authentication. Then device validation, that is something all of us know, but when we do, for example, when we do the SSL connection, we don't do the device authentication, right? Only thing we do is like the user authentication. And the funny thing about SSL is many people do not understand this. That is, when you have the SSL or TLS tunnel, that is just the encrypted tunnel. We don't have any specification on the security of the both endpoints. Now, there are very famous or infamous stories about during the Iraq war. DOD had a TLS connection to one of the facilities there, and without knowing that this was terminated on a machine which was in a cardboard tent or something like that, right? Which had access given to everybody. So this was like a very secret information was being tunneled because people are very confident this is TLS, no problem, right? But the endpoint was not secure. So the key here is like the device needs to be authenticated to, validated to, and dynamic firewalls. That is an interesting concept with SDP. We know firewalls. Most of the time, what we do is like based on the requirements, we will statically configure the firewall. Whereas with this is going to be dynamic. Based on the application requirements, the opening and closing will happen dynamically. The application binding, so like I said, we are trying to do the micro-tunneling to application. And SDP is not a theoretical concept anymore. We have commercial implementation. There are many companies who use SDP. For example, Coke, Verizon, Mazda. This just to give an example. And there are multiple companies offering SDP like services to enterprises. Just to quickly the workflow. There are three major elements in an SDP system. If you can see it, the controller. This is a security brain, SDP controller, and this is the client, SDP host, and this is what they are trying to access. That's accepting SDP host. So I don't know how many. Are you all familiar with the SDN, software-defined networks? Yeah. In software-defined networks, the idea is. Let me talk about the regular networks. In regular networks, we have routers. When the packet comes, the routers will decide, based on the routing table, it knows exactly where to route the packets. In SDN, what we have is that routing intelligence is taken from the routers and put it on the cloud. That's a controller, right? When the packet comes, instead of routers, we are using simple switches. That's a cheap alternative to routers. And then they will be given flow tables. And if the flow table does not have an entry corresponding to the incoming packet, it will be sent to the controller. The controller will tell exactly where to send it. And then based on that, the switch will be reconfigured to do that. So a similar thing, if you want to compare SDN and SDP, SDP, the security orchestration is happening from the SDP controller, right? So that's orchestration is the key. In SDN, the network flow orchestration happens from the control layer, whereas now the security orchestration is happening from the SDP controller. So the idea is this: SDP controller is where all the security credentials, everything is going to be located, right? And this is a client who wants to access some service from these servers or gateways. But at the same time, this guy does not even know where the service is. So the first thing it has to do is it has to connect to the SDP controller and authenticate themselves, and then request for that particular service. And then the controller will go back to the servers and then get the details. What is IP address, what are the credentials the user has to use, etc. And that information will be passed to this one. And based on that information, they have to create a packet called SPA, single packet authentication. So what happens is everything on these servers is going to be blackened or darkened. Nobody knows this, right? And that information, once they pass that information to the controller, and then it will come to the client, and the client will create that single packet authentication and send to the dark dynamic firewall. And then looking at the SPA, the firewall can authenticate that packet, and it will just open that particular port. That's it, nothing else. And that opening is valid only for that particular session, right? If you want to have, if you terminate that session and want to start a new session, you have to go through the SPA process again, right? So that makes it very secure. All these connections, so we have this dotted lines and the dark lines here. These are all mutual TLS. That means, what is the reason for this mutual TLS means? When we do SSL or TLS, most of the time, the security or authentication happens only one way. The client authenticates a server, even though we can do both ways, we don't do it. Whereas in this one, it has to be mutual authentication. In the standards, we have 4 different ways of SDP implementation: client to gateway, client to server, server to server or client to server to client. So let me quickly say what this is. The idea is you have a client, you have a server, right? Sometimes, and if you're an enterprise, you don't want a client to be having to do this SPA process to access every application which they have access to, right? For example, let's say I have an account to Microsoft Word, whatever, not Word, what do you call it? Microsoft Office, right? So one possibility is like I can go through this SPA process to access every different sub applications under the Office, right? Instead, I can put all those sub applications behind a gateway. And then if I have the authentication of the gateway, I can access all the application. That is like a middle ground between what we have now versus what Sdp offers, right? And then client to server, one application, one connection to client. Server to server, instead of client, there could be two servers connected to each other, or client to server to client. Sometimes you want to connect to a client who doesn't have the Sdp access, right? So you can go through an Sdp process and connect back to the client. So that way, you can connect between two clients with secure Sdp provisioning. So what are the different protections? I may have already mentioned these things, but let me quickly go through the remote hidden services infrastructure. We already talked about this. Servers are blackened, means all the applications are unknown. People don't even know the IP addresses. Mitigates DOS attacks. Now, I will show a quick slide on a use case. You can prevent the denial of service attack. Let me maybe explain here itself. How can we prevent the denial of service attack? You can do a denial of service only if you know that exists, right? You don't even have a connection to that. Whatever Smurf attack or anything that we use, we need to have access to those IP addresses, which is not familiar to them. By the way, when you have this darkened applications, the IP addresses don't even have to be the same all the time. Every time you connect to the same application, their IP addresses could be different. And attack detection, whenever there is an attack, you can detect it because people are trying to connect to it without an SPA. We talked about the mutual two-way encrypted communications. What I haven't talked about is device authentication. Sdp requires a device authentication too. Right now, the technology mainly people use are based on device authentication with assigned parameters. Can you think about some device authentication like this? For example, when I make a phone call from my cell phone, the telecom network is making an authentication of my device based on the device ID, right? But again, that's an assigned number, which can be forged. So the people are thinking about, okay, device authentication is good, but at the same time, it has to be something intrinsic to the device. And we'll talk about some possible ways to do that. Disallows forged certificates, disallows man-in-the-middle attack. Whenever you have a mutual TLS connection, the man-in-the-middle attack is prevented, right? At the same time, we have to make sure that people will not accept forged certificates, right? And later on, we are going to talk about FIDO, which will definitely allow or prevent any kind of phishing-based man-in-the-middle attacks. Need to know basis, we already talked about this, but one point I want to emphasize here is easier forensic. So now, the way we do it is we have three separate entities, right? The client device, Sdp security controller, and the server. And then what it does is like a very clear delineation of the protocol handoffs. Because of that, you can do a forensic analysis on the device to see if the device was compromised at any time. Dynamic firewalls, I mentioned about dynamic firewalls multiple times, but the idea here is membership-based dynamic enclaves. The static rule is deny all. That means the firewall is always closed, right? And then when the SPA comes in, it is authenticated, and then it will look at the different parameters, IP address, source, destination, and the port, source, destination. The four values need to be bound. All right. So this is the secret sauce here, the single packet authentication. How does it work? This is to initiate any communication. You need to have a single packet authentication. The kind of things we have here is, we have IP at the header, the TCP header, and then there is an ID here, there is a password, and there is a counter, and then there is a hash here. So the final hash is nothing but to protect the integrity of the packet, right? The secret sauce here is the password here. I'm sorry, where is it? Yeah, the password here. And many people get completely worried. This password is in the clear, right? So how does it work? The idea here is every time you generate an SPA, it is going to be a new password. And this password is generated based on the secret that is shared between the server and the Sdp controller, which has been shared with the client through the mutual TLS, right? So that is protected. And now you can use that information to generate that password and then send to the server so that the SPA can be authenticated. So I want to compare this SPA with some other technology that was known before. Have you heard of port knocking? Yeah. The idea of port knocking is this. You want to securely keep the ports closed, right? And if somebody wants to enter or given access, the idea is they have to present certain number of port numbers in some sequence. It's like the old gangster deal, right? There is a closed door, and then you have to knock in certain sequences, 2 knocks, and then 4 knocks, then maybe 3 knocks, right? Then you know that the person coming in, have the shared information. Similarly, the port sequences you can set, and then people thought that's a fantastic idea so that you can have this dynamic port opening and closing, right, based on the port knowledge. But it had some problems. The problem is this, these port numbers need to be the clear, right? If I'm sending this port numbers, port numbers are random numbers I can generate, and that's a secret shared with the server. And that's a very secure deal, but somebody can observe it and they can send the same sequence, and then the port will be open. Another problem is we are using IP here. When we send IP packets, we don't have any guarantee how they are going to be delivered. Sometimes it is not going to be delivered, right? So either we are going to get these ports out of sequence, or sometimes I may not even get certain port numbers in the same. So the ideas seem to be good, but we need to have better ways. So what people did early on is, in order to make sure that the out of order reception, they will delay the sequences, right? First port number delayed for some time just to make sure the packet arrives there, and then the second sequence, third sequence, etc. But that takes so much time just to get security there, right? So people decided, going to go for a little more robust one packet authentication, and then this works very well. I mean, this is standard. There's an ROC out there. If you look for SPA, you will see the details. This is a simple capturing of how SPA works. So just give you more details. The ID, agent ID, counter value, and one-time password. That is the key, right? That is this seed is a secret that came from the server, from the Sdp controller, right? And then this counter value is also in the clear. So if you go back here, how do I go back? Yeah, here, this is in the clear, this is in the clear. Yeah, so at the receiving end, they will take the counter value, and then the seed, that is secret. Seed is not sent here. So the seed and the counter value will create the password. So that's how they authenticate. Is that clear? Yeah, every time the seed is going to be different, and the counter value will also be different. All right, so a couple of use cases here. There is a host machine here, and then there's a kind of a database server. You want to access it. So instead of giving access straight to the database servers, you have to go through the Sdp controller, and this is accepting host, right? So this is like a gateway kind of implementation. You have multiple servers here, which will have the data, but you need to have authentication only to the gateway, and then behind that, you have multiple servers, right? So this is another IoT application. Sometimes people think, the granularity has to be high not to do this. That's not true. So when you have so many number of devices, this is a smart meter, which we all have in our houses now. One of the early problems for power companies was connecting them securely to the servers, and now they use STP-like application, right? They can have, so this the smart meter doesn't have to have a wholesale access to their backend server. Rather, they will be connecting only to their application. So that was a big deal, right? Because this is an embedded device, somebody has full access to that device that can be compromised anytime, right? So they want to make sure that whenever they are not compromised, they have secure access. At the same time, even if it is compromised, they don't have access to anything else. Yeah, so this is, again, I don't have to explain, this is a DDoS attack, but the main idea, I have, this is a slide from Beverly Labs. The multiple steps are there. By the way, do you have access to these slides now, or how does it work? Yeah, this is, yeah, you can share this slides with other people, yeah. So the idea here is like, in order to have DDoS attack, you have to have access to that IP address. Right, this is protected, and because of that, any DDoS attack can be detected early on. Yeah, detected and prevented. All right, so so far I'm just talking about the good things about STP, right? There are some bad issues also, or limitations. The first of all, the compromise on the trust broker system, because when we are saying everything is going to be dependent on the trust or the protection of the STP controller. Right? If that is compromised, things would be a problem, right? So from the security point itself, and that's a problem. But at the same time, this is a question I, as a kid, always had. Where do we have this malls, for example? I always used to think that you don't want to have like 5 different shops selling the same stuff at the same place. That's too much competition, right? I would rather have it in somewhere else. Then the idea is this, right? You can provide a lot of infrastructure common to them that will, there will be some amortization of cost, right? Infrastructural cost is going to be very, very low. Same thing happens STP controller. Now, instead of protecting 500 different servers, you're just protecting one STP controller. So you can put not the 500 times resources, but 10 times resources, but it is going to be 10 times secure than each of those servers, right? Then there is a single point of failure. This is something we always talk about in fault-prone computing, right? That is single point of failure. Whenever everything depends on one central point, if that fails, then we don't have access to anything that is being overseen by that system. So one key aspect of this is just like SDN, software-defined network. There also we have a network controller. It's a logical central location. It doesn't have to be physical. So most of the time we have to provide redundancy. When we say redundancy, we even have to provide geographical redundancy, right? One controller could be in Baltimore and the other could be in Houston, that geographical diversity has to be there. Then compromise user credentials, combined device and user authentication. So this is very, very interesting and daily occurrence, right? Think about this. Most of the time when we try to access some systems, we are using user credentials, that is login name, password. That's it. Doesn't matter whether I'm accessing from your laptop, my phone, doesn't matter, I have access, right? And sometimes when you go to your bank account, for example, nowadays, when you log in, if you have reset your browser or from a different laptop, it will say that, oh, the device is not familiar to us, so you need to go through the OTP or whatever, right? You have to access. Even at that time, they are not really doing a device authentication, right? So when we log in, they are getting so much information about the IP address, the network ID, etc. So they are looking at 25, 30 different parameters to make sure that this is a familiar context, right? If it is not, they are going to complain and they are going to use the OTP, right? But the truth is, many places, when we use user authentication, there is no binding. I will give you an example. For example, how many of you use Starbucks applications on Starbucks, right? So yeah, and the great deal about Starbucks is like you don't have to use your credit card, right? You can use the barcode from your application, show it to their reader, and then they will charge you. And then when you run out of money, they will get money from your credit card, right? But it has a security hole in it. The security hole is, if I get a copy of that barcode, I can send it to 50 different people. They all can use the same barcode, and then access your account and charge their copy on your account. We have verified it. We have tested it. What is that? Yeah. So is it something we cannot deal with it at all? That's not true. That's the laziness of it, right? Now, for example, that barcode could have been bound to that particular phone. They just don't do it, right? I mean, as long as the barcode is there, I mean, you can use it. That's exactly what Sdp wants to do, right? They want to bind the user with the device. So they will not only authenticate the user, but they will bind the device also with it. Service isolation for legacy applications could be difficult. Let us see, even when we talk about zero trust, the biggest problem people see is like the cost. What's the cost? Because it is not like a flag day, right? I mean, we can never have a flag day for security networks or anything because we have so much investment in the legacy systems. So we need to have an easy transition from the legacy to the new system. All right. So more interesting things. Now, how can we strengthen Sdp after hearing about all these vulnerabilities or limitations, right? So I'm going to talk about 3 technologies, which my PhD students work on some of this, right? The first one is on identity. So if you ask me and any security researcher, you all agree that so much money is there, or many people, when they talk about cybersecurity, only thing they are worried about IAM, identity access management, right? So that is the first part, identity. So if you can provide the right authentication to people and systems, you're in good shape. And one of the new technologies that is evolving, I can guarantee you, in the next 5 to 10 years, we are all going to be passwordless, right? How do we use it? We use a technology called FIDO, Fast ID Online, which has already been used, right? Many people use it, but it's going to be eventually everywhere. Right now, like all these retailers like 7-Elevens and Starbucks of the world, I mean, they want things where people can use just by branding their phone or whatever, right? They don't want people to worry about their passwords and stuff like that. But they're not doing it properly. The security is not there. But eventually, they will have the technology where you can just walk in and still be authenticated because of the technologies we can bring together. I will spend some time on FIDO. Now, the next one is a device security. That is, I have been talking about the device security right now is based on the assigned values. Instead, we need to have intrinsic values and properties of the device we can use to authenticate, right? So we'll talk about something called PUFs, physical unclonable functions. PUFs were originally casted for RFID tags. The biggest problem RFID tags had was cloning. With the PUFs, you can avoid cloning. And the session security, that is in Sdp, even though we talk about completely continuous monitoring and forensic analysis, the main focus so far has been on the initial authentication using SPA. Once authentication is done, session is on, and the business will take their hands off, right? The Sdp controller is not part of the session at that time. But we believe, there has to be continuous monitoring so that we can make sure that the session is going to be secure. Because the session could be for a long time, right? It could be for 1 minute, or it could be for 1 day. So it's not just good enough, you have authenticated session starting today morning, and then what happens today afternoon, right? It still has to be secure. So you have to have something called real-time protocol monitoring, so which I will talk about. Let's quickly talk about FIDO. How many of you are familiar with FIDO? Last idea online, yeah. So the idea here is you have to go passwordless, right? Am I running out of charge here? Okay. Thank you. So you're watching this. Yeah. So this is becoming very big, right? What is the basic premise here? So right now, if you look at it, the way we authenticate is we come through the client system, we provide our login and password, and then it is securely authenticated from the server because they keep the hash of our password, and then they can compare the hashes, and then you get authenticated. But the problem with this is there is a lot of man-in-the-middle attack. Many people think once you have OTP, there cannot be man-in-the-middle attack. That's not true at all. OTP only makes sure one thing, that is, you have two things with you, right? So, for example, I'm very sure most of you use Duo as an OTP. When you log in, the Duo is going to send you a confirmation, and then you get to press it, right? So only thing it guarantees is like the user who is trying to access knows the password as well as carries the device, right? How can a man-in-the-middle attack can happen through phishing? So what happens is that, let's say I'm going to Chase. I connect to Chase, and then Chase is going to send me the OTP, right? That's how the security loop is there. Instead of Chase, if because of phishing, if I go to a fraudulent site which looks like Chase, right? When I give the password, they can forward that password to Chase, and then actual Chase is going to send me onto my phone the OTP, and then I will be sending that either the PIN value to the fraudulent site, and they will forward it to Chase, and Chase will think that I'm the legit person, right? So the phishing and man-in-the-middle attack can happen on OTP. What FIDO does is providing security so that will not happen. So let me explain how that works. With FIDO, there will be a local authenticator, right? You can use a biometric to authenticate with the device, and then the device authenticates with the server. And that authentication is not through hash and password, rather public key, right? So you will have the private key on your authenticator and the corresponding public key on the server, which understands FIDO. And now each time you try to connect, the server is going to send you some random number, and then you have to sign it, use your private key, and send it back so that it can authenticate. So the good thing here, first of all, even if somebody compromises the server, they are not going to get your password, related password, rather a public key, which you can publicly supposed to be public, right? You don't care. You have the private key, and if you know it is compromised, you can change your private key, public key. Another important aspect of this is because of the authenticator there, it is not to the device of the user to determine whether the site is fraudulent or not. So if there's a fraudulent site in between, man in the middle, that link is also attached to the secret that you are going to sign with your private key, which you are going to send back to the server. And now the server will look at the link, and then they will realize that this is not their link, and they can easily detect there is a man in the middle, right? So they can reject the connection. So that to me is the biggest value that FIDO offers. And FIDO, like I said, is becoming more and more prevalent, and pretty soon all the universities and all the enterprises, everybody will be using FIDO, which will be very easy and the security to do it. And so why am I saying with respect to Sdp and zero trust? Right now, when I have the client, I'm authenticating with the Sdp controller. I could use a regular login and password. Instead, if we use FIDO, it is going to be even more secure. That's the idea. And in FIDO itself, right now, they're using login and password, but they could have they have the provision for the device authentication too, right? quickly about physical uncrownable functions. The idea is very simple. Right now, the biggest problem with embedded systems is when the user has the complete access to the device or the system, they can open up and mutilate it whichever way they want, and they can use optical, electrical, power analysis, whatever, to find out the secret key into the computer, right? So you want to, and then once it is there, then you can clone it. You know, for example, simplest example I can give you is toll tags, right? If somebody gets a toll tag, and if they can get the information inside and in the toll tag, they can create any number of toll tags. Or your access IDs, you can clone IDs and get access to the places, right? So RFID tags, I mean, all these, right? I mean, our access IDs and then toll tags, so they have RFID tags. So the biggest problem with RFID tags for the launch was the cloning. How do you avoid cloning? So the PUF technology allows prevention of cloning. What is PUF? That's physical unclonable functions. Let me give you one type of PUF which we are going to talk about here. You can insert a very small circuit. It could be like a 30-40 gates, right? Just to create kind of a ring oscillator kind of thing. Then the idea there is it is going to create a pattern for it. So that is, if you give a challenge, it is going to give a response, right? But this response is going to be entirely dependent on the physical impurity of the substrate. Make sense? And the good news here is, like, whatever new challenge you give, you are going to get a unique different response. So that immediately will make an ID for that device. So now what happens? You know, like anybody can see that circuit, they can go implement exactly the same circuit, but their response is going to be different because they cannot control the physical impurity there, right? So that becomes a unique ID for it. And then, but there are challenges there, right? Think about this. In an RFID tag, you're looking at 3-4 cents RFID tag. You don't want to have, so let me step back. The biggest benefit of those kind of challenge response pairs is you can have one-time passwords. What is this one-time password? You can give a challenge to your tag. You're going to get a response. You know exactly what the response should be. You ID the tag, right? Next time, you will not use the same challenge. You use a different challenge because that's one of the tags, or the replay tags. Now, if you use the same challenge all the time, somebody could see the challenge and then they can reuse it, and that because they could be a raw reader, right? Every time that challenge is coming, you know, the reader will load the information. Whereas if it's one time passwords, you know, every time the challenge is going to be different. Think about it. 3 cents tag sitting there. You want to use one time password. What it means is the server has to keep millions of challenge response pairs so that they can uniquely identify that tag. That is not going to be safe. So there are new protocols, you know, something called OPRA, you know, overt challenge algorithms. And so the idea there is instead of just giving one challenge, they will give a combined challenge. One challenge is open and the other challenge is closed. So open challenge will be taken by the tag and generate a response, and that use that response to open the closed challenge, and then give the response back to the server. So there are ways of doing this, and which immediately makes it scalable. You can replenish it and things like that. I mean, there's so many different advantages, you know, when you look at the symbol. But you know, how does it SDP work with this? Now we kept talking about user authentication and the device authentication. Now for the device, instead of using an assigned number, you can use the unique ID. By the way, the PUF doesn't have to be a semiconductor implementation. Nowadays, you know, for IoT devices, there is something called RFID, radio frequency IDs. You know, the idea there is like when you transmit, you know, you can look at the signals and then put it through some machine learning algorithm so that you can identify what kind of time. You know, because the transmission, just like the semiconductor substrate, is going to be naturally controlled, so that each one of them will have different IDs, right? Now comes the real-time protocol model. How much more time do I have? 10 minutes. Okay. Real-time product. Okay. Yeah. Let me quickly say this. In telecom and networking industry, one of the biggest problems we have is knowing whether the protocol is secure, right? Most of the time, the urgency is to get the protocol out for functionality. Right? That's time and memorial. That's how we design things, right? IPTCP, everything, right? And now talk about complex telecom systems staying at and coming at 5G kind of protocols, right? Every time the network engineers are looking at to come out with protocols which will function. So now the question is like, function is there, but does it have additional functions there so that people can use it to get there for nefarious purposes, right? That's where the security hole happens. So what is the best way to protect it? Early on, people said, okay, when we have a protocol, we can formally verify to make sure that it doesn't have any holes in there, right? But the formal verification takes time, and that's also post-design. And plus, network engineers are not verification experts, right? Most of the time, there'll be a separate group of computer scientists who can do the formal verification of the protocol. But then again, there is a problem. Even if a protocol is formally verified, when you implement those protocols, depending on what software what language you're using, they will have additional security problems, right? So the actual security considerations or evaluations need to be happening at the implementation level, right? So that becomes a very difficult problem. So one possibility here is, if you implement the protocol, we know exactly what are the current functionality it should have. Then if we can continuously monitor the operation of the protocol to make sure that it doesn't deviate from the actual functionality, then we can detect the security. So how do we do this? For that, one possibility is you have to have an omnipresent observer who will look at all the transactions that's happening in the network to make sure that it is not going through any kind of nefarious states, right? So that was very difficult. So we proposed this RTPM long time back in the mid-90s. At that time, it was not very acceptable to people because who is the central node, right? All of a sudden, when SDN came, people said, now we can do this, right? And Sdp controller is nothing but the central observer who's doing. So when you look at the Sdp based zero trust architecture, what we have the capability now is a central controller who has the visibility to the rest of the nodes. So now, after the session authentication, if you have continuous monitoring of the session to see that who is sending what, you can make sure that the protocol is progressing and the session is staying secure, right? This again, the beauty of this is it's highly scalable. For example, if I have a connection to my blog site, which is talking about the latest best deals on Amazon or whatever, I don't care about the security of that, right? At that time, I may say I don't need any security at all. At that time, I won't monitor at all. Whereas if this is a connection I'm doing to my bank, that needs to be secure. At that time, I would say I want monitor session. The monitoring frequency could be every minute or every 30 seconds, whatever. So I can scale it, whatever the level of security I want. And plus, it's reliable too, right? For example, whenever there is any kind of protocol failure, the system will know so that you can have alternate packets too. So I think I will stop there. But let me put one more slide here. Zero trust approach, almost like an imperative to support digital acceleration, right? Digital acceleration, what we mean is people should be mobile first and applications should be developed by anybody and accessible to anybody. So zero trust is an important thing. People needs to understand it better, and commensurate investment has to happen. Otherwise, it's not going to happen. Though touted as most advanced implementation of zero trust, Sdp needs improvements, and we already talked about 2-3 different ways. I mean, there are multiple other ways we can do that. As application spaces converge, technologies need to converge. Let me make an important point there. Right now, the problem is there are so many different standards and applications and technologies out there. For example, zero trust people, not many of them know Sdp. I invited somebody who's writing a book on zero trust to my class. And then when we talked about Sdp, I mean, just asking what is Sdp? That disconnect is there. And then there are some people talk about SASE now, the secure edge, people who see all these things in the big picture, they understand that's a convergence of zero trust, SDP, etc., the SASE. And then when you look at 5G, for example, the telecom lines, many people just don't know what is a CPU and zero trust, etc. But security is a paramount for 5G deployment. So when these conflational technologies happen, we have to consider security as a whole something, right? We cannot just have bits and pieces. So that's my point. So I will stop there and if there is some questions. Yeah. Sure. Thank you. Excellent question, right? So that's a trade-off that we have. For example, my PhD student right now is looking at the performance trade-off. If you were to do RTPM, the question is like how often. So how do you have the central observation? Only way we can observe is like these client nodes and the host nodes sending packets to the Sdp controller. So multiple things can happen. If you're the degenerate things, right? The extreme end. Everything that the client is sending to the server, we can send to the Sdp controller also, just to have a second level authentication. But that is going to clog the whole network, right? So if you have hundreds of thousands of the client host connections, then everything goes to the one Sdp controller that is going to clog the whole network, right? And then Sdp controller, the computing power, the performance is going to come down and everything is slowed down. At the same time, the other extreme is don't send anything to there. So at that time, you don't have any continuous monitoring. So depending on, where you trade off, right? Can you have this performance hit, but I want to have security? Or do I want to have high performance with less security? But at least that gives an option, right? Right now, there is no trade-off. Either you have security or you have performance. So now we can say for performance, I can have more. Yeah, but it is the problem. And then I mentioned one small thing, right? For example, some of the enterprises, and instead of have that Sdp control every application, they will put multiple applications, tens of thousands of applications behind one gateway, and that will scale and the performance will be better. So you have to see the whole picture and then decide, where you will provide some kind of levity so that you can get that better. Yeah, absolutely. I mean, I personally, that's a good point. Sdp control itself, they are going to identify certain features of it, which can be kind of commoditized, right? So that they can have their own accelerators for it, so that they can put it there, so that particular functionality will be done by that accelerator, right? And Sdp controller by itself is going to be the server farm name is gone, right? It could be a cloud, elastic cloud, which can switch in and switch out in any number of resources, so that you can keep it. Yeah. I mean, those kind of things are happening. I mean, SDN itself, people were worried about the performance because of the centralized one, right? So now, people are trying to see how it can be distributed, and then ASIC accelerators can be used, etc. Good point. Good point.
As a question, yeah.
Yes.
Okay. Yeah. So yeah, thank you for all the information. So when I first saw the extension
Yeah. So, again, it's not going to be a worldwide Sdp controller. But each enterprise will have an Sdp controller. And so it's going to be hierarchy. But if you, for example, internet, when we use internet, is essentially control. Some people will say yes, because DNS is kind of supposedly simple, right? Everybody has access to that. But still, this is to be entity involved with some very servers and the good news there is like you don't have to go to a DNS server. So that kind of a hierarchy is going to happen. In DNS, there's not a hierarchy, right? Sometimes I don't even have to get out of my laptop. I can get out of my go to the next level. So that kind of a hierarchy, but logically speaking, it's on.
Okay, I have a quick question about dynamic firewalls. So you have a per application firewall.
Yes, it is a firewall, but the opening is going to be per application. So you are connecting to an application.
Based on it.
Based on. You had a question too? Yes. Yeah, good question. It's like any authentication process, right? If you're going for the first time, they will have to use multiple steps to authenticate you. And then once you're authenticated, then your device information could be with the server. So the next time you don't have to go through 5 different steps. Instead, you can directly go there. Yeah, but there is no way for the Apple server to know about your device ID first time. So we have to go through that registration process. Yeah. So even when we talk about FIDO, you have to go through a registration process. Once you register, then it's transparent to the user, right? You go to the authenticator with your cell phone, you use the biometric, your kilometric, whatever, right? And then you are getting connected without your knowledge, but the backend process is happening. No. So for example, let's say the first time you're connected. At that time, they will ask you your email ID, and so that they can send information or phone calls, depending on what level of security they want, right? They will use multiple ways to make sure that it is you. Or sometimes, they will ask you for information, right? If you are applying for a loan or something like that, sometimes they will ask you, can you tell me the last withdrawal amount you made? Or so that they have some kind of very clear way of identifying you. And once that is done, they're just looking at your device ID from there on. Next time when you go there, you don't have to answer these 4 different questions. Does it make sense? Yeah.
All right, we will stop here. Thank you very much.
Thank
Excellent.
you.